whose name I already forgot, which is Job and Esther Technologies. And he's going to talk to us about how to develop native cross-platform games now or in the future if you're not doing it right now. So please welcome Markku KERO and give him some applause.
Thank you. So my topic today is the development of native cross-platform games. That's a technology-focused topic. Who here are game developers? Very good. Who here are not game developers? So mostly we'll be right on topic. So first and foremost, let's try to get what I mean. So when I say cross-platform games, I mean something like this. There's a lot of platforms that you have to develop for, right? Who has had to encounter these things in the past? So these are now, especially in the time of mobile gaming. Of course, much of the mobile platforms are very important for us. So this would be the level of platforms, like the number of platforms we need to talk about. And when we say cross-platform development, we of course mean the ability to develop software that works on all those things. Now, when we put the word native there, developing native cross-platform games, the word native is used in many different ways. Here's what I mean when I say native. Native applications are such that they interact with the underlying software platform directly without any interpreters, any mediators in between. Is that can you relate with that definition? So when we say, look at the platforms earlier, each one of them has a different notion of native. Now, what you see there are platforms, and on top of each of them, the programming language that you use to develop for each. And it's always different. For Android development, Java is considered native. For iOS, Objective-C is considered native. On Windows Phone, that's C# and so forth. They all have their different software platforms. Now, usually, we see it this way. If you go to the forums, discussions on the internet, people are debating whether to develop native or develop cross-platform. Have you been a part of such conversations? Have you seen those? No one has seen conversations like that on the web? There's a lot of that going on in LinkedIn and on other programmer forums, whether to develop natively or develop cross-platform. That's usually exclusive. Either you do one or the other. Now, traditionally, when you say developing native, that means you choose your platform. So when you make a game for iOS, you make it for iOS and iOS only. You develop it in Objective-C using all Apple approaches. That will not work on anything else. Or you choose to go Android, you do it in Java, and you focus it all on Android. In practice, that approach doesn't really last. The usual outcome there is either your game doesn't make it, so you leave it at that. But if your game is successful, you'll always want to expand. So what happens there is that you develop it for iOS with Objective-C first, became successful, now you want it on Android, and you'll need to develop it again. Who has gone through this? I see one hand, very good. That's a common practice. When you need to expand to different platforms, you have to recreate your app over and over again. At the worst, you'll end up having the same game developed 5 times. And imagine, for a development group, how will you maintain that? you have 5 code bases of the same game. When you add something, when you fix something, you need to do it 5 times exactly the same way. So it's a problem. Now, that leads us to developing cross-platform. And what you really want to have there is one code base for each project. So you develop the game once, you have one source code for the game, and you target different platforms. Who would want to do that? Is there anyone here who would want to do that? Yes, there's a lot. And usually, to do that, you'll need to use some kind of a tool, right? We've been mapping the different tools for this. We've categorized different tools that are available. Without going into great detail of the details of each, the bytecode approach has to do with putting some kind of interpreter or virtual machine that will handle the cross-platform functionality. C++ approach has to do with using C++ and considering that cross-platform as long as C++ works. And then numbers 4 and 5 here represent more or less a web technology approach, HTML, JavaScript approach. Now, by and large, now if you go back to the forums on the web, you'll see people complaining about these things. They will tell you that the downloads become, they tend to get big. The apps tend to use a lot of memory. The apps might not work as fast as you would want to, and you cannot access all the features of the underlying platform. So moving forward with that, specifically with gaming, you would want to have performance. Would you say? Would you want to have performance in your games? Yes. So given performance constraints, you do not really want to have an interpreted or a solution where the processor is being used for translation on the fly. So more or less, I'll rule out such approaches, scripted and the bytecode approach. Although you can develop very fine games with that, it's just that if you are looking for the optimal solution, you want the maximum performance. So architecturally, that's not the best bet you'll get. I have ruled out numbers 4 and 5 for the same reason, performance issues. Although there is ongoing debate on whether HTML5 performance will reach acceptable levels. But as of now, I'm sure you are all aware of developers moving away from HTML5 because of performance. Same has been said about the embedding a web browser approach. So in practice, what happens is many game development tools and platforms are using C++, most probably because of this. It's at least performance angle there is better. Now with C++ though, it comes with its issues. C++ games, first and foremost, do not run on the web platform. I'll say something more about that later. Secondly, C++ works on a fairly broad scope of platforms, but it does not work fully on all of them. Specifically, when you talk about Android and Windows Phone, you can now do C++ development on those things, but the applications are not fully considered part of the system. The API access to all the features is either reduced or very uncomfortable. So they're not really full-scale citizens on those platforms because it's not native to the platform. And then there are platforms where you cannot do C++. Notable is Firefox OS, where they have actually said they have no intention of bringing C++ support to the platform. So Windows Phone 7 was like that. There was no way of doing C++ development on Windows Phone 7. Windows Phone 8, now there's some. But the fact remains, as new platforms come out, you cannot rely on C++ always being available. And lastly, I would say, many tend to say that C++ is hard. The developers here, would you agree? Of course, once you learn it and you love it, you'll enjoy it. But for the most part, people are telling me C++ is tricky to program. And most probably, it takes longer time, bigger cost of development. So, how do we solve this? So let's look at that again. So the platforms that we're looking at, all kinds of different languages there. I see a few trends in the platforms now that are coming up. I see that a lot of them are banking somewhat on JavaScript. There's either it's HTML5 or other web technologies or just JavaScript. JavaScript seems to be enjoying some sort of popularity right now. At the same time, I can see C++ coming in, as in even platforms like Windows Phone, where C++ was not available before, now it is. On BlackBerry before, you cannot do C++, now you can. On Android, or ever since, it's a Java platform with a little bit of C, they have been increasing the C++ support ever since. So trend-wise, I can see C++ rising along with JavaScript. I can see Java actually declining. Mostly the Java-based platforms are legacy platforms, aside from, of course, what is the dominant Java-based platform now? What is the most popular platform that is using Java for development? Android. Thank you. And of course C#, but only on Microsoft technology. So trend-wise, JavaScript and C++ would be large platforms. And now what we would want to do is have a game, and that will work on all those things, right? Even whatever future platform we may have, we would want our game to be able to be played on that. But how? And the solution that I am proposing here is source code conversion, which is simple enough. You see, source code here is the code that you as the developer will make. You feed it to a development tool, and it will become source code for another language. This has been, of course, discussed by programmers for the longest time. And again, if you look at the forums on the web, many will say that this is impossible to do. And there are academic people who will prove why it's, even in theory, it's impossible. But nevertheless, if we can do that, now we will have games that will run not only on the platforms of iOS and Android and Windows Phone and whatever. The games will also be available on the web platform. That means web browsers, whether mobile or desktop, because they can be converted into JavaScript right now. The other advantage here is that the games will not be native regardless of the platform. So if you are targeting a Java-based platform, your games will be native on that platform. If you're targeting a C#-based platform, the game will also be native on that platform. And you'll get around those many usual issues. And that means now that will include platforms that do not accept C++, like Firefox OS and whatever else is coming in the future. And lastly, you don't necessarily have to develop using C++ if you are not really a C++ person. So, comparison to the earlier slide with the red colors, the green colors here will now be normal installer size. Nothing is added to the installer. It does not use more memory. There is no interpreter added there that will increase your memory use. It does not need to interpret while running, and it does not decrease your performance, and it does not limit your API access. And you get to target all the platforms. And that's what I meant with my title. So that's my introduction. Congratulations. Are you still with me? So that's what I mean by developing native cross-platform games. Full disclosure, that is what we do in Job and Esther Technologies. We produce a tool called Ikela that does exactly that. We convert programming languages. The source code is fed to a compiler that we make, and it produces source code for JavaScript, Java, or C, or Objective-C in this example. So to make an iOS game, it will be compiled from Objective-C with Xcode to become a iOS app, or from Java into Android app using the Android SDK. Or the JavaScript code will run in the browser as is, no plugins required. Now, we're not the only ones who think so. So in terms of trends, have you heard of this? Have you heard of a tool called Mscripten, if that's what it's pronounced? That's another tool. It converts C++ code into JavaScript. There's another product called Mandrill that converts Android or iOS to HTML5. There's another project called asm.js. Have you heard of this? The intention here is to increase the performance of JavaScript by reducing what it does to a smaller set that can run faster. The objective is to have the web platform work faster. There's NaCl. Are there any chemistry majors here? That's not what it's about. That's short for native client. That's Google's initiative for enabling processor native code to run in web browsers. There's a lot of other languages for a full list. A lot of languages that can be compiled to JavaScript now. Now, that shows us a trend. So what those that are listed are development projects or small solutions, but they do not do like everything. But they do reveal a trend for us. And I see the trend that they are evolving the web platform into something that is going to be more efficient. They actually have a target. They're targeting it to be as efficient as Java. Supposedly, hopefully, they will reach a level where it is only 2 times as slow as processor native code. That's a trend that is being worked on by many right now. And there's a trend of targeting that platform by compiling other code to work on the web platform on the browser. And that trend really says there's no browser plugins or extensions anymore. The trend is really going away from that to compiling straight to these platforms. And interestingly, that has to do with the evolution of the web platform. It has nothing to do with HTML5. You have heard of HTML5? And HTML5 is still being standardized. Hopefully will be released next year. But the trend seems to show that it may be dead on arrival. The industry has moved on with other initiatives by that time. We will see. So if we put that into a future-looking mindset, what I see is that the C++ approach will be there. You can do C++ code for many platforms, but you may not be able to target them fully from C++. What I also see is that, like I said, the web platform is being evolved towards something more efficient. Additionally, like I said earlier, Java is on a decline, but it remains important as long as Android remains important. If ever Android declines, we will have no more viable Java-based platforms for gaming, at least. And likewise, C#, the .NET platform, is important as long as Microsoft remains important. So in terms of cross-platform, I will say that the scripting, the virtual machine, the interpretation angle will not be able to address the requirements for gaming. You will need performance, and those will by definition sort of hinder some of the performance. C++ gives you performance, but you will not be able to address your full market. There's other kind. There are hybrid solutions here, like C++ and C# combined, which work today, but they will be very hard to compile to other platforms. So those will sort of stick you in web browser plugins, and while it works, it may not be future-proof. So, and if you go back to those forums where they discuss these things, you'll hear that native platforms are always the way to go. Now, just to tell you, what does that ask from us? First and foremost, it asks of us a mindset where we can adapt to the technologies that come. And it asks of us a willingness to expand our approach technology-wise. We need to be able to say that the platforms I've been using now will not be viable in the future, and I need to do something else. And that calls us to work together to make those things happen. So when we do, I would just invite everyone to work towards such a world where we can continue to have a diverse set of platforms, but where we can work easily on them all. Thank you.
Please give him some applause. Now, our next session is going to be in 7 minutes.